In this video, we will go over another type of integral problem. This problem will involve partial fractions, but I'm going to call it a type 4, repeated quadratic factor. And if you want, you can pause the video here and attempt this problem. Now, if you notice the inside, we have an x squared plus 1. But what's different about this part is that this whole piece is actually squared. And because of that, we have a repeated quadratic factor. And we need to do something different. So we split it up again. So a divided by x, because here we have an x, plus, because of this piece, we have x squared plus 1, we say plus bx plus c divided by x squared plus 1. But because it's a repeated quadratic factor, what we need to do is say plus dx plus e divided by parentheses x squared plus 1 squared. And like always, the next step would be to multiply the common denominator, which will be x times parentheses x squared plus 1 squared. And this will give us x raised to the 4th plus 1 is equal to a times x squared plus 1 close parentheses squared plus bx plus c times x squared plus 1. So in reality, what we're doing is we're multiplying this whole piece by each term. And if you notice here, for example, we get divided by x, and that's why here there isn't an x, because the x is essentially canceled. And the last term, dx plus e times x, because here we have x squared plus 1 parentheses squared, which is the same as this, but we don't have an x, so we multiply by x. And the next step would be to expand, so x squared plus 1 squared would give us x raised to the 4th plus 2x squared plus 1. Then we do this piece, so x times x squared would give us x cubed, x times 1 would give us plus x. And the next step would be to expand, so we would have ax to the 4th plus 2ax squared plus a. Then we have this piece, so plus bx raised to the 4th plus bx squared plus cx cubed plus c times x, so cx. Now we do this piece, so dx times x is dx squared plus e times x. So now we have this right here. And here we said it was x raised to the 4th plus 1, but in reality we also have 0x cubed, 0x squared, 0x. And now we will group the like terms. So we have ax to the 4th, we also have bx to the 4th. So we can say this, parentheses a plus b, x to the 4th. Now we have cx cubed plus, now we have for x squared term. So 2a, we also have a b, we also have a d. Now we have cx and ex, so parentheses c plus e, close parentheses x. And finally, we have a constant a. So we can say that x to the 4th is equal to parentheses a plus b, x to the 4th. So we can say that 1 is equal to a plus b. Then we can say that 0 is equal to c. We can say that 0 is equal to 2a plus b plus d. We can say that 0 is equal to c plus e. And finally, we can say that 1 is equal to a. So right off the bat, we know that 0 is equal to c and 1 is equal to a. So I went to the next page just for more room, and this line was the previous line. So this line right here, 0 is equal to c plus e. We know that c is equal to 0, so we can say that 0 is equal to 0 plus e, and so e is equal to 0. So here we have 1 is equal to a plus b, and we know that a is equal to 1. So we can say that 1 is equal to 1 plus b, and therefore b is equal to 0. So now we can say that 0 is equal to 2a plus b plus d, and we know that a is equal to 1, so we can say that 0 is equal to 2 plus b is equal to 0 plus d. And so now we can say that d is equal to negative 2. And so now we just swap our values for a, b, c, d, and e. And this is what we would get. So we would get the integral of parentheses 1 divided by x plus 0 plus negative 2x divided by x squared plus 1 close parentheses squared dx. Now I'm going to split this integral into two parts. I'm going to split it into the integral of 1 divided by x dx minus 2 the integral x divided by parentheses x squared plus 1 squared dx. I simply just move the negative 2 to the front. And so this is what we get. Now this first piece is easy to get the integral. So the integral of 1 divided by x dx would be ln absolute value of x. Now this piece right here, we need to do the u substitution. So we can say that u is equal to x squared plus 1. Then our du becomes 2x dx. And so we can say that du divided by 2 is equal to x dx. And so now this piece right here, x and dx, will get swapped with du divided by 2. And this piece inside, x squared plus 1, will get swapped with u. So we get ln absolute value of x minus 2, the integral 1 divided by u squared, times du divided by 2. And so this 2 cancels, and so we get ln absolute value of x minus the integral 1 divided by u squared du. And so we can rearrange. So instead of saying the integral of 1 divided by u squared, we can say the integral of u raised to negative 2 du. Now we can easily take the integral of this piece. And so we would get this right here. And so this is a negative, and this is also negative, so it becomes positive. So this is what we get, ln absolute value of x plus u raised to negative 1 plus c. And the last step is to swap our u with what we said u is equal to, which is x squared plus 1. And so this right here is our final answer. And that's all we need to do for this type of problem.